Good day and welcome. So today in the video we're going to do prime factors, but we first need to find out what prime numbers are. Okay, so let's look at the following. Okay, so first of all we need to know what a prime number is. A prime number is a number that only has two factors, which is 1 and itself. So it's a number that has factors, but only two factors, which is 1 and itself. Let's look at an example. We look at 2, 3, 5, and 7. What number can go into 2 without leaving a remainder? That would be 1 and 2. What number can go into 3 without leaving a remainder? That would be 1 and 3. Okay, so a prime number is a number that only has two factors. Remember, factors are smaller than the given number. Now we need to look at prime factors. What are prime factors? Which is what we're going to talk about today. Those are any factors of a number that is also a prime number. So it can be a factor of any number as long as it is a prime number. Not the number itself, but the factor should be a prime number. Let's look at a few examples but before we get there, we need to list a few prime numbers because there is quite a few that we need to memorize. And we memorize them because we're going to use them so often in our math. When we are working with prime factors, or when we're even working out the lowest common multiple or the highest common factor. Okay, so this is the numbers that we need to memorize out of our head. It is good to know more than we should, right? So we should actually know all the numbers from 1 to 100 that are factors, our prime numbers, that are prime numbers. But we are going to mostly use these numbers in our equations, and that's why I emphasize on them. Okay, so there are quite a few ways to actually find prime factors. Okay, we call them factor trees, or we call them division rules. Okay, I'm going to show you both. Let's look at an activity. So let's see. Question number A states that we need to find we need to write the following numbers as the product. So product of their prime factors. Okay, so we need to write the following numbers as a product of their prime factors. Now, first of all, product means multiplication. Okay, so this means you need to multiply the answer, and it should include prime factors. So let's look at our question. Number 1 says 36. Number 2 is 48. So again, we're going to use the prime factor tree as well as the division rule for both of these equations. So you can decide by yourself which one would work best for you. To be honest, I only understood the prime tree when I was studying to be a teacher. I always use the divisibility rule. So that is what we're going to practice today, and you can make up your own mind at what you're going to try and how you're going to use it. So first of all, the prime factor tree. Okay, so with the prime factor tree, we write down the number first. So 36. Okay, we always write, before we start writing anything about prime numbers, anything like that, we always write our prime numbers that we have in our heads already, which is 2, 3, 5, 7, 30, sorry, I forgot 11, 11, 13, 17, 19, and 23. Okay, so now we ask ourselves, we always start from the smallest number. What number can go into 36? Can 2 go into 36? Yes, it can, because if the number ends in a multiple of 2, it can be divided by 2. And 6 is definitely a multiple of 2, so we can divide it by 2. So 2 here. How many times does 2 go into 36? Let's see. 2 goes into, let me just say quickly. It's 15 for 30. Let's do this. So 36 divided by 2 goes in 1, 2, 1, 6, and then 8, so it's 18. I hope you know how to do long division, guys. I'm not going to teach you that. You're supposed to know that. If not, look at my video. You'll definitely see it there. Alright, let's see. Next one. Can 2 go into 18? Yes, it can. So, 2, and how many times? It goes in 9 times. Can 2 go into 9? No, it cannot, because it's not a multiple of 2. Now we go to number 3. If the digit of the number adds up to a multiple of 3, it can be divided by 3. So can 9 be divided by 3? Yes, it can. 3, how many times? 3 times. Now 3 is already a prime factor or prime number. So we stop right there. And then we take a beautiful other color. I normally do this to make emphasis on what the prime numbers are. So you have your prime factors over there, but hold on, we're not done yet. We need to write it as a product of their prime factors. So we need to say 2 times 2 times 3 times 3 equals to 36. Or we can say 2 squared, because it's 2 2's, multiplied by 3 squared, because it's 2 3's, equals to 36. And that's what we do. Okay, now let's work this out as a divisibility rule. Okay, I'm going to do the divisibility rule in green so we can see the difference. So the divisibility rule is quite put into blocks. So this is more artistic kind of thing, and the divisibility block is more of a in block kind of thing. Yeah, so we draw a T line like this, okay, and then we write our 36. So then we ask ourselves, what number can go into 36? Can 2 go into 36? Yes, 2 can go into 36. How many times can 2 go into 36? 18 times. Okay. Can 2 go into 18? Yes, 2 can go into 18. How many times? 9 times. Can 2 go into 9? No, it cannot. Can 3 go into 9? Yes. 3, how many times? 3 times. Can 2 go into 3? No, it cannot. Can 3 go into 3? Yes, it can. How many times? 1 time. And over this side, this beautiful side over here, is our prime factors. And then we do exactly the same thing that we did before. We write it as a product of its prime factors, which means it's 2 times 2 times 3 times 3 equals to 36. And there you have both ways. So this one is quite straightforward. This one is basically the same as this one, but I feel that this one is, for me personally, a lot better than this one because it's curvy and I'm artistic. So if you like this one, you can do this one. If you don't like this one, then you can do this one. Both of them are exactly correct. You will not get a mark wrong either way. Okay, so let's look at 48. So I'm going to do it with the prime factor tree instead of the divisibility rule. Okay, so 48. Can 2 go into 48? Yes, it can, because this is an even number. How many times? 24 times, because 2 goes into 8 4 times, 2 goes into 4 2 times. Can 2 go into this number? Yes, it can, because it's an even number. How many times? 12. Again, 2 goes into 4 2 times, and 2 goes into what? 2 1 time. Can 2 go into 12? Yes, it can. It's an even number. How many times? 6 times. Can 2 go into 6? Yes, because it's an even number. How many times? 3 times. Can 2 go into 3? No, it cannot. Is 3 a prime number? Yes, it is. So we stop right there. Okay. So now we circle all the prime factors. So it pulls our eye. We can see that we have. Okay. And then we write it as a product of its prime factors, which is 2. But how many 2's? 1, 2, 3, 4. 4 2's. multiplied by 1, 3 equals to 48. Okay, that is how we work with prime factors. This is how we work with how we calculate prime factors. Okay, so I'm going to give you a few equations, and I'm asking you to figure it out before I give you the answers. Okay, so question number A is work out the prime factors of 30. B, work out the prime factors of 24. C, work out the prime factors of 1125. And then last one, remember the most difficult one comes last, A, B, C, D. We have 9240. Now let's see if we can do this. So pause the video here, right here, and then do the calculations. Then check, do I understand this work? Does my calculations match that of mine? Okay, if our video takes a little bit longer, we will go over to the next video, and I will link it up in the description, so don't worry about that. But let's start with our equations. I'm going to do this in blue. So we have 30. 2 goes into 30 15 times. 2 cannot go into 15 because 15 is not an even number, so we're going to work with multiple of 3. 1 plus 5 is 6. Yes, 3 can go in there. So it's 3. How many times? It's 5 times. 5 is already a prime factor, which means there we have our prime factors. So we have 2 times 3 times 5 equals to 30. Number B, 24. Okay, can 2 go into 24? Yes, it can. It's an even number. 2, how many times? 12 times. 2 goes into 4 once. 2 goes into 4 twice, and 2 goes into 2 once. Can 2 go into 12? Yes, it can. How many times? 12 times. Can 2 go into 12? Yes. How many times? 6 times. Okay. So then it's still an even number, so 2 can still go into there. How many times? 3 times. And 3 is a prime factor. So there we have our prime factors, which is 2 to the power of 1, 2, 3 2s. So 3 times 3 equals to 24. Okay. So I'm going to make a little bit more space for the following one. Let me just get that right. Okay, so we can't see our prime numbers anymore, so let's just copy the prime numbers over here. It's 2, 3, 5, 7, not 9, 7, 11, 13, 17, 19, and 23. Okay, so now we have 1125. Okay, so it ends with a 5, which means 2 cannot go in there. It's not an even number. So let's add it together to see if it comes to 6. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 5 gives us 9. And 3 can go into 9, which means 3 is definitely a factor. So how many times can 3 go into 1125? And this is where the long equations comes in. We have our division equation, 1, 1, 2, 5, and we have 3. 3 goes into 11 3 times, so that's 9. Subtract 11 minus 9 gives us 2. Bring down the 2, goes into 7. 7 times 3 gives us 21. That leaves us with 1 and 5, and then 3 goes into 15 5 times, which means our answer here is 375. Again, 3 cannot go in, 2 cannot go in there. It's not a prime. No, it's not an even number. So let's look at 3. 3 plus 7 is 10. 10 plus 5 is 15. Yes, 3 can go into 15. So we do it 3 again. Okay, and it seems like our time is going up or getting up. See you in the next video.